Assalamualaikum and good morning to our lecturer, Dr. Nazat Toshima. Today, we are from Group 6, GBS0026. We will be presented the answer for our assignment 2. Our group consists of 4 people, all from Faculty of Science. The first presenter is me, Alia Izandi. The second presenter is Herda Misha. Third presenter is Nur Kirana. And the last presenter is Hadina Alia. So first, let us read the question together. Make an informative and creative mind map of the evolution of the star, including one solar mass star and one massive star. The second question is, relate the evolution process with the formation of solar system. Moving on to the next slide is the mind map where we have constructed. The mind map is basically showing a simple way of evolution of the star. Generally, we can see that the star is always start from the nebula, then the path will break into two. One path is where one solar mass star will born, and another path is where the massive star will born. So, let us dig into this mind map to get more information on how star was born. As we can see, it all starts from nebula. But what is nebula? Nebula derives from the Latin means little cloud. It's a cloud of dust and gas found in the interstellar space. They are known as the basic building blocks of the universe, including the star. They are made of very spread out and dust particles resulted from the dying star explosion. Slowly, they are contracting, become closer to each other due to the gravity, forming a clump known as a protostar. It will become bigger and the gravity will become stronger until eventually they get so strong and they have reached enough pressure, so the material at the center started to heat up. So this is where the nuclear fusion occurred. And this started the beginning of the star formation. The probability of the either one solar mass star or massive star will born.
And now we will talk about low and medium mass star. In the core of the sun, hydrogen is being converted into helium. This is called nuclear fission. It takes 4 hydrogen atoms to fuse into each helium atom. During the process, some of the mass is converted into energy to keep the star hot. A red giant forms after a star has run out of hydrogen fuel for nuclear fission and has begun the process of dying. A star maintains its stability through a fine balance between its own gravity, which holds it together, and the outward pressure from ongoing thermonuclear fission process taking place at its core. A red giant becomes a planetary nebula when the last of its fuel is spent and nuclear fission stops within the star. At this point, it ejects its out layers of matter. This layer becomes the planetary nebula surrounding the white giant star that was once the stellar core of the red giant. White dwarf is surrounded by the planetary nebula. It is called white dwarf because it emits light, causing it to be white in color and small. When a white dwarf exhausts its own surplus of carbon, oxygen and free-flowing electrons, it will slowly burn out, it will no longer emit light and transform it into a black dwarf.
Massive star has masses over 8 solar masses. Its high temperature and pressure allow carbon and oxygen fusion to occur, followed by neon, magnesium and silicon fusion. When the star had consumed its core supply of hydrogen fuel, it becomes a red supergiant. The star's outer layers expand while the core continues to shrink. When ion builds in the core, the fusion process ends. Because ion fusion uses more energy than it generates, the core gets incredibly hot. Heat generates pressure, which prevents it from collapsing. Gravity of the star attempts to crush the star into the tiniest ball possible, but the nuclear fuel burning in the star's core generates a lot of outward pressure. This pressure opposes gravity's inward compression. When the star's hydrogen fuel is out, it cools down, causing the pressure drops and gravity wins. A supernova occurs when the star collapses. The core of a star remains after a supernova explosion. If the core's mass is below 3 masses, the star collapses into a neutron star, a dense and compact star believed to be mostly formed of neutrons. If the core mass is greater, the stars become black hole, a cosmic body of extremely intense gravity from which nothing, not even light, can escape.
Now, the second question asks us to describe the relationship between the evolution of stars and the formation of solar system. So, around 4.5 to 4.6 billion years ago, the solar system was formed from the nebula through the process of stellar evolution. In cold temperature, the gravity pulled the gases in the nebula to the center, clumping them together and makes the center part denser. Then, the dense part began to collapse under its own gravity, called gravitational collapse. Thus, the sun is formed at the center, in which most of the collapsing mass is from the sun. The remaining mass of the material in the nebula that was not absorbed by the sun was flattened and held in orbit by the sun's gravity. This produces the protoplanetary disk from which the planets, including the moon, would form. When the pressure inside the gas increased, creating the nuclear fusion, the sun started to ignite and blast a stellar wind that cleared out the remaining gas and dust from the solar system. The rocky debris that remained is represented by the asteroid. And last but not least, we would like to express our special thanks and gratitude to Dr. Nazat for everything that you taught us. And there is also a QR code here which contains the references to the information that we used to complete the assignment. Thank you.